Let us discuss about how to construct truth table for a given propositional function. In the last video, we discussed what is a propositional function and examples. Now let us see for the propositional function how to construct a truth table. Yeah. So basically, what this truth table indicates, it displays the relationship between the truth values of compound prepositions constructed from simple prepositions. Okay, so what does it mean? Suppose if we consider this propositional function, suppose if we consider this propositional function, that is P implies Q, P implies Q, and PRQ. Okay, so basically, how I construct the truth table for this means, so this compound prepositions you divide into smaller components and construct the truth table, and finally construct for the bigger one. So this is how we construct a truth table, right? Now, the first step, the important step in this is how I construct a truth table. Okay, how many rows will be there in the truth table? So here that depends upon number of prepositions. Now, suppose if you see here the given prepositional function, how many different prepositions are there? If you observe carefully, there are only two. One is P, second one is Q. That's all. So since there are two different prepositions, so therefore the number of rows in this truth table will be 2 power 2. 2 power 2. So 2 power 2 is 4. Suppose if there are three different propositions in my given propositional function, then the number of rows in the truth table will be 2 power 3. So therefore 2 power 3 is 8. Therefore there will be 8 different rows. So the number of rows depends upon how many different propositions I have in the given propositional function. So in general, if there are n different propositions, then there will be 2 power n rows in my truth table. So that is the first point you should understand. So in this case anyhow, however, in the first example, there are only two different prepositions, right? So 2 power 2 is 4. So therefore, there are 4 rows. Now, next point is how I construct these combinations of false, true, false, and so on. So here, internally, we are following the binary number representation for the given decimal numbers. So suppose if we take, so 4 rows means what? The numbers you take by decimal numbers 0, 1, 2, and 3, right? So these are the 4 starting with 0, and these are decimal numbers. So 0 in binary we write as 0, 0. 0 in the binary we write as 0, 0, and 1 in the binary we write as 0, 1, and 2 we write it as 1, 0, 1, 0, and 3 we write it as 1, 1, right? 1, 1. So please recollect, it's a basic topic, how I convert even decimal number to binary. So if 0, 1, 2, 3 are my decimal numbers, equivalent binary numbers are 0, 0, 0, 1, 1, 0, 1. Okay. Now in the truth table, of course, we can take zeros and ones, or even we can take false and truths. Okay. So it is either way. So some others in the truth table they take zeros and ones, and some others they write in the truth table false and true. Okay, so they are same. Okay, so 0 or false are same, and 1 and 2 are same. Okay, so anyhow in this truth table I have taken false true, and earlier you would have seen I have taken 0, 1. So just to understand you that all are same. So either I can take truth table 0, 1, or true or false. Okay, now so now here I have taken first one is false, false, nothing but 0, 0, then false true 0, 1, then true false 1, 0, and true true is 1, 1. Okay, so this is how first I take combinations of truth values for all the prepositions. So I have 2, I've tried 4, so therefore all the 4 combinations are this: false false, false true, true false, and true. So I just recommend every one of you, so please follow this pattern. So don't take in a zigzag way. That means first false false, then true, then don't take in a random way. So please follow systematic order. So whatever we follow for representing equivalent binary numbers for the decimal numbers. So I just recommend you to follow the same. That is 00011011, or if you convert into false true, then it becomes false false, false true false, and true. Then fine. So once I decide this, how many rows and what are different combinations, if this part is over, then we have to focus on how to divide this given proportional function into comfortable component. So here I can divide obviously p implies q as one component. So first I do for p implies q. Then in the next column I can do for prq. Okay, and after doing these two, then I can do p implies q and prq. So that is the reason if you see truth table, first I did for p implies q, then I did for prq, then I did for p implies q and prq. Okay, so this is the final values. The last one is the final answer for the truth table. Okay. Now let us see how to construct the truth table for PM plus Q. So I already told you the prerequisite for this video is you should be thorough with all connectives like and, or, implies, by implies, exclusive or, NAND, NOR. So all these connectives should be thorough. Because you should not refer again and again the same slide or the same material for the truth table. So the truth tables of the connectives must be there in your mind. So please remember, so implication when it is false, so we know that implication is false only in the TF case. If the first proposition is true, second one is false, only in that case it is false, remaining all the cases it is true. So therefore, please here, only in the TF case it is false, and remaining cases it is true. Okay. Now coming to PRQ. So how I construct PRQ? Why I am constructing PRQ? Why? Because your second component in the given proportional function is PRQ. So therefore, so PRQ, and what about R when it is true and when it is false? So the connective R is false only when both the propositions are false. The remaining all the cases it is true. That means in the FT case, TF case, TT case it is true. So therefore, you see here only FF case it is false, and the remaining all the remaining three cases it is true. So with this, the second one is over. Now I have PM plus Q here, and I have PRQ here. Now it is P implies Q and PRQ. That means between these two columns, you have to apply the AND connective. Between these two columns, you have to apply AND connective. And we know that how AND works. So that is the reason for the construction of truth table, you should be very thorough with all the connectives. Otherwise, there is no use. So therefore, once again, I'm telling. So please refer. If you don't know, if you don't have all these things in your mind, so please refer. Remember, write once, twice, thrice in your notebook. Practice the truth tables for the basic connectives. Then only come for this video. Okay. Yeah. So I need to apply AND between these two columns, right? So therefore, AND is true only when both are true, both the propositions are true, and remaining all the cases it is false. What are the remaining cases? That is FT, TF, FF. So in all these three cases it is false. Therefore, the first one is TF. So TF is false. We know that true and false is false. The second case is true and true. So it is true. And the third case is false and true. False and true is false. And the fourth we got as true and true is true. So therefore, this is the final truth table. So this is the final answer. We need to construct a truth table for P implies Q and PRQ. So this is the final answer. Okay. So this is how we construct a truth table. So step one is how many rows we have to decide. So that depends upon number of prepositions we have. If there are n prepositions, then there will be 2 power n. Then for all these prepositions, we write different combinations. In that way, there we follow binary number representation of the decimal numbers. Then the given proportional function we divide into smaller components. Then gradually we gather, and finally we take the big expression, actual given expression. Then we construct. So this is how we construct a truth table for the given proportion.